Hello and welcome to this video. In this video, we are going to learn how to create and run a one-off process on AWS EC2. In a few chapters, we will learn how to prop up AWS Batch, which will allow us to run batch processes on AWS. Now, if you have AWS Batch set up, that is still going to be the best way to run even one-off processes on AWS. However, there could be instances where you just have to spin up an EC2 instance, run a process, and then kill the EC2 instance. That's a very valid thing to do and something that's really useful to know how to do, and that's what we're going to learn how to do in this video. So let's go to EC2. In the console here, I want to point out key pairs. I have a key pair. If you do not have a key pair, you'll need to create one so that we can SSH into our instance. After you create the key pair from the console, that will automatically download it to your machine. I just moved my key file into my home directory, and you can put it in whatever location that you want on your machine. Let's go back to the dashboard. We'll see that we have no running instances, so let's launch one. I'm going to select Amazon Linux 2 AMI. It's pretty trusty and pretty handy. We will see that the instance type that is selected by default is a T2 micro. That is free tier eligible, but it's pretty small. It only has 1 vCPU and 1 gig of memory. As you might recall, our explore.py file is a little bit on the meaty side, so this just isn't going to cut it. I'm going to select T2 2x large. That has 8 vCPUs and 32 gigs of memory. That should do the trick. This is not free tier eligible, so it will incur some cost. However, we're not going to be leaving this instance up for very long, and we should be able to keep costs pretty minimal as long as we just shut down our instance whenever we don't need it. So just remember to do that. I'm going to go to the instance details. Actually, not going to change anything here. Not going to change anything on storage. I'm not going to add any tags. I am going to configure a security group. I'm going to create a new security group called EC2 security group. And I'm just going to give the description the same name. I do want to be able to SSH into this instance. That's the type that is selected by default. That by default comes across on port 22. That's always where SSH traffic comes across. On the source, I want to select my IP address. That's something that I highly recommend doing, even though this is also protected by an SSH key. Just saying that, hey, only traffic that comes from this IP address can SSH into it is just a nice little blanket of security. All right, let's review and launch. This all looks good. Let's launch. So again, we talked about key pairs. I'm just going to choose an existing key pair, and I acknowledge that I have that. And let's launch it. So as my instances are now launching, I can check that out. And this is typically pretty quick, so we're just going to kind of hang out here for a few seconds while this goes from pending to running. And yep, that did not take very long, did it? Our instance is already running, so we can get into it. I'm going to copy the public IPv4 DNS to my clipboard because we will need that. And let's SSH into this guy. So SSH -I, and then I'm going to reference my PIM file. That's the SSH key. And then EC2 user, that is the username for any EC2 instance. And then I'm just going to pass in that public IPv4 DNS. So again, a very simple command here. SSH -I, or -I should say to be more formal. And then I'm referencing the path to my PIM file. I just put that in my home directory, and I'm currently in my home directory. And then my username is just EC2 user, and then at the public IPv4 DNS. Yep, I want to say yes here, and boom, I am in my EC2 instance. So this is just a plain old Linux instance, and we can run bash commands like we had been before. So if we issue an ls, we can see there's nothing there. I can do a touch, notes.txt. That file is there. I can remove it. Confirm that it's removed. And I can also run a clear command. So we are just able to operate pretty much like we have been. We are just SSH'd into a remote instance. So as I mentioned, this is just a pretty plain old Linux instance. I think by default, the AMI that we use does have Python 2 on it, but of course we don't want to use Python 2, we want to use Python 3. So let's install that. And we can do that by following the directions in this document, and don't worry, I will link this in the book. So we're going to use yum to install Python 3. Yum is just a package manager, pretty little handy deal. Cool, that installed it for us. Again, yum is just a package manager. It's basically just like Homebrew. Not just like, but it functions like Homebrew, I guess I should say. So we can verify that Python 3 is installed. Actually, I'm just going to say which, so I can type. And we can see that, yes, indeed, we do have Python 3 on our machine. Let's go ahead and clear. Now, just because we have Python installed doesn't mean that we have pip installed. We actually need to install that separately. So again, we can do that based on this documentation. I'm just going to run a simple curl command first. Pretty quick and painless. And then this will also verify that I have Python 3 installed. I need to run that script that curl just brought down via Python 3. Yep, successfully installed pip, and we can just do another confirmation. Pip 3 version. We do get a little bit of a warning message here, but that does, in fact, confirm that we have both Python 3 and pip on our machine. And then I'm just going to exit the Linux instance right now, and we can see that the connection was closed. All right, so we are back in our terminal on our local machine. We're not SSH'd in anywhere. So what we want to do now is we want to copy files from our local machine onto our EC2 instance so we can use them. There's a couple different ways that you can do this. You could, for example, use FileZilla. We're just going to use the scp command, and that's going to reference our PIM file, so everything's going to be encrypted. All right, so I've just brought up PyCharm, and I want to point out a couple of things. We're going to copy over 3 files. So we're going to copy over explore.py, requirements.txt, and our CSV version of our data. So the reason we're going to do this is because I don't want to take the time to jump through the hoops of getting this script to run directly on EC2. There's just a couple of small complications. For example, in our regular script, we went to Secrets Manager and got the secret. We connected to the database via our private Python package. So we need to whitelist IP addresses both in our bucket policy on AWS and in our security group on AWS for MySQL. If we need to get that IP address, we can just copy it here, so that's not too terribly difficult to track down. And then we would also need to set up our Linux instance to be able to query more or less Secrets Manager via our AWS key and AWS secret. Again, none of that's hard to do. We've walked through how to do that on your local machine. You just have to replicate that on the Linux instance on EC2, but I just don't want to take the time to jump through all of those hoops, because really the point of this is just showing you, hey, how do I spin up a EC2 instance, run something on it quickly, and then spin it down. So that's all we're really going to be doing here. So if you need to be able to query MySQL or connect to Secrets Manager, the information on how to do that is located in this book. All right, so that was a little bit of a digression that maybe took a little bit longer than what it should have, but nonetheless, here we are back in PyCharm. So let's go ahead and pull up terminal, and then we're just going to copy these files onto EC2. One thing that I do want to point out about explore.py is again, we're just referencing a CSV. Here, we're not connecting to the database, and really there's going to be no actual difference in what we see locally compared to what we see remotely on EC2 because the CSV and what's in our MySQL instance are just identical. All right, so as mentioned, we're going to use the scp command. Again, I'm just referencing that PIM file. And then I need to pass the path to my local file. And now I'm passing in my remote location. I need to go back and copy this DNS. And then I'm going to place the path, and I'm just going to call this site churn data CSV. I'm having trouble typing here. Please forgive me. You'll notice that I'm just putting this in the root of the Linux instance. I'm not putting it in the data directory. And this looks promising. It tells us that it is porting that over. And 100% done. All right, let's copy over the explore.py file and the requirements.txt file. So I can just amend this command slightly. Actually, I'm going to start here at the end and work my way to the front. We're going to do requirements.txt So note, this data is in Scratch, in the Scratch directory. Or I should say this file is in the Scratch directory. We've talked about the Scratch directory before. That is just where we kind of throw junk in, more or less things that we just kind of need temporarily or we don't want to delete right away. The Scratch directory is in our git ignore file, so none of this is pushed into version control. And likewise, that CSV file is listed to be blacklisted when pushing to our git remote repository. So nothing that we're actually doing, none of the files that we're actually referencing locally are getting pushed into our remote repo because these are just kind of trial and test files. So again, just remember that we're using our Scratch version of requirements.txt and not the actual production version, which is in our root directory. That looks good. All right. Now, lastly, we need our explore.py file. It's difficult to say for some reason. That looks good. All right, we should be in good shape. Let's go ahead and SSH back into our instance. Just going to go up a few commands. That one looks like what we need. We're back in. If we issue an ls, we see that, yep, we do have those files that we copied over. So we are in great shape. So let's go ahead and do a pip3 install on our requirements. pip3 install -r. That would be useful. So this is downloading our files for, the setup.py files and installing our libraries for us. We'll just kind of hang on here while it's doing its thing. And now we would be able to run our script. So let's go ahead and just kick this bad boy off. We're not actually going to let it run all the way through because it does take a hot second for it to run, but we're just going to run it, verify that it can be run, and then kill it real quick. So say Python 3 explore.py. And yep, the issue is that we didn't completely clean up our explore.py file. So we were referencing some columns in there that are only pulled in when we use the database. So we can actually pretty easily fix that. So let's do that now. Go back to PyCharm, and yeah, I'm just gonna delete these two columns here. PyCharm autosaves for me. So let's just rerun our scp command on that. And then SSH back in, gonna clear. And run the file again. Yep, and we can see that this is creating our tsne visualization, so this is exactly what we want. I'm just gonna go ahead and kill this because I think it, on my machine, it typically takes 6 or 7 minutes, and we don't really need to do that here necessarily for this video. So keyboard interrupt, yep, that's fine. If I issue an ls, I can see that, yeah, we actually now have our output files and our output images. And if we look at create exploration directories, that's what we wanted to happen. So this is working on EC2 just exactly like it works locally. So let's go ahead and talk about now, how do you get files off EC2 onto your local machine? Again, we're just going to use the scp command. So that's going to be pretty simple. So let's cd into output files. We don't have anything in here, but let's just go ahead and create a file. And let's get out of our EC2 instance. So we're back locally. Now we can basically just use our scp command in reverse to take things from our EC2 instance to our local machine. Again, I'm having extreme trouble typing. Please forgive me. Now I'm going to pass in the -r flag. So this means recursive. So this is going to allow us to copy a directory. I think that I still have the DNS copied on my clipboard. Yep, I do. Called output files. And let's just put that locally in output files as well. If I issue an ls, I have a lot of junk in here, but I can see that, yep, I now have output files. If I cd into output files, I can see that, yep, I have file.txt. So I was able to take that file from my EC2 instance, or pardon me, that directory from my EC2 instance, and copy it and its contents locally, which is pretty nifty because if you recall that once we run explore.py, it's going to put everything in these exploration directories that we create up top. So you don't want to copy the files one by one. You just want to be able to recursively copy the directory remotely, locally. So all we would need to do to get this to run exactly like we did locally was just SSH back into our EC2 instance and rerun explore.py, and then just let it run for the 5 or 6 minutes that it needs, and then copy everything locally. So again, that can be a really useful instance if you're running out of memory locally, if you need to multi-process something and you only have a limited number of cores on your local machine. If you just needed to run like a huge grid search on something, or if you're running something really computationally expensive that you just needed to use the multiprocessing library for, you could spin up something on EC2, which is like 16 or 32 cores, and let it run for 30 minutes, and that's going to be pretty cheap still, which is pretty nice. Again, please recall that these files I just put in Scratch, the Scratch directory. That doesn't get checked in the version control. That's kind of just like a Scratch location. And we're just using the CSV version of this and not using our in-house Python library. That just kind of makes this process a little bit easier. Again, all you have to do is just list the EC2 instance's IP address in your MySQL security group and in your AWS S3 bucket policy. And then you would also need to set up your EC2 instance to be able to pull from Secrets Manager. And we've talked about all of those steps previously, so I'm confident that you would be able to do that should you want to do that. But at this time, this concludes the video. I'll include a link to this guy here in the book, and I will also include the versions of these files in a gist below. And again, you can put your site churn data wherever you want it. I still have it in my directory here, although I'm always using the MySQL version of the data. I'm just keeping it here because it is not allowed to be pushed into version control based on git ignore. I have CSV files not getting pushed into the remote repo. So this is just a local file that I have here that doesn't get checked into version control. Anyway, I think I've probably been long-winded enough, so let's go ahead and stop this video now. Thanks for watching, and I hope you found it useful.